Okay, kids, we're going to go over what Hardy-Weinberg equilibrium actually is. And I kind of told you what it is in class. Now, remember, P is the frequency of the dominant allele. So if I was putting that there, it's just how we get, and remember, it can be any letter. So Q is the frequency of the recessive allele. So that's a small a. So let's put a small a down here. All right, P squared is the individuals with dominant traits. That's two big A's, okay, for instance. This one would be heterozygous. That's one big, one small a. And then finally, Q squared equals what we know as homozygous recessive. All right, so the recessive. And that's the only one that we actually do know what the number is. So let's take a look at one of the problems from your handout. In a population that has a Hardy-Weinberg equilibrium of 38% of the individuals that are recessive. So they're telling you that right here, Q squared, and I'm going to put it right down here, actually. And we're going to put it here. Q squared equals, and we're going to put it as 0.38, because that's 38%. And that's where we're going to start. Okay, so I'm going to find the calculator on my computer, and I'm going to get that up. So hopefully we can see that on the screen. And remember, right over here, I'm going to block our instructions, and then I'll move it out of the way. I want to take the square root of 0.38. So I'm going to hit 0.38. And the one I'm going to hit the square root is right over here. So I'm going to hit the square root, and we're going to round this to 0.62. Okay? So I'm going to shrink that down, and now I'm going to put this up over here, and Q equals 0.62 because we rounded it up. Let's make this go up a little bit so I can make it look pretty for you, just so it's symmetrical. All right, now we're going to take a next thing. It says I'm going to take $1 minus Q. We just got Q. And that's going to give me P. So what's $1 minus 62 cents? 1 minus 0.62. Won't that give me 38? So I think it's going to equal the same thing we just had. So that's going to equal 0.38. All right. And what is that? That is P. And what is P? Remember, P is how many capital A's that there's a possibility of having in a population. All right, so we now have both those numbers, okay? And I'm doing this on one of the harder problems to try to make your life easier. Now, what we're going to do next is we're going to have to take P and square it. So I'm going to have to take 0.38 times 0.38. All right, now there's a couple different ways I can do that. On here, I'm going to clear the calculator again. I'm going to hit 0.38 times, remember squaring something is times itself, 0.38. And what am I going to get? 14%, right? Around 14. All right, let's try a different way. So let's take 0.38. And let's hit this button, the square button, and we get the exact same number. So there's two different ways that you can actually do that. And I showed you on there. So now we have the answer, and I can go down here, and that equals 0.14. So that equals now P squared. And that's how many individuals that we're going to see that are homozygous dominant. And that's actually what they asked for, and heterozygous individuals. So we have to do the next one too. So this probably still shouldn't be very hard to get 2PQ, and actually it's PQ, not PG. Oh, well, I screwed that up. So we're going to take 2 times P times Q. All right, so in this case, I'm going to have 2 times, okay, what is P? 0.38. What is Q? Times, okay, 0.62. And how about if I actually get a point over here? And then we're going to get how many heterozygous in this population should have this particular trait. So now I'm going to get my calculator up again. I'm going to clear it one more time. And I'm going to go 2 times 0.38 times 0.62. And I go equals. And I have 47%. So that's going to equal 0.47. So if we total all these up, okay, technically they should all add up to kind of $1. Remember, P plus Q, okay, and that really is the whole formula, that P plus Q always equals 1. So if it's close to 1, that's fine because we're rounding up and rounding down. But P and Q is what? That's 62 cents and 38 cents is the other one. So P is 38, Q is that adds up to $1. So it does meet the criteria. Now, hopefully you find this one useful, and perhaps maybe I will do one more problem for you. Okay, so we're going to look at one of the last problems on your worksheet, and this is one of them. It says in a population that is in Hardy-Weinberg equilibrium, 160 out of 200 individuals are Rh positive. Now, Rh positive, okay, is dominant. You can see that it's obviously dominant. So how many of the recessive do we have? So if dominant is, and I take 160 divided by 200, and I'm just going to do this. I mean, I know what the answer is, but it's got to be 80%. So I'm going to take 160. I'm going to divide that by 200. She get 0.8. All right, and we do get 0.8. So I knew that that was 0.8. So that's 80%, isn't it? So that equals 0.8. We already know that one. That is, and what does that equal? That's P, isn't it? All right, it's not P squared, but it's P, right? The frequency of the dominant allele. So what does Q have to be? What is 1 minus 0.8? That equals Q. So that would be 0.2. And this is just asking what the frequency of both of those alleles are. But I'm going to show you how we can even use this, and we can figure out what each one of these are. Let's say the problem actually wanted to be Q, and we need to go through all this. All right, so the first thing I have is, remember now, this equals Q, and we need to have Q squared. So over here, I'm going to do it on this side this time. So I'm going to start with 0.2 times 0.2, because we got to square it to get Q squared, because we want to find out all these different things. So now we're just going to do it kind of in the reverse. So what is 0.2 times 0.2? And I bet you a bunch of you think it's 0.4, and you're wrong. So watch. 0.2 times 0.2 equals, there it is, 0.04, and that's a big difference, okay? So you really can't make mistakes like that, and don't automatically always assume that you know the answer on this one. So the answer is 0.04 is actually Q squared, okay? And I'm going to try to make this so we can still see this. So I found Q squared if I needed it, okay? Now, we still have this, and we've already figured out that 1 minus 0.2 is 0.8. So we got 1 minus, we're going to do it in reverse, 0.2 equals 0.8. We already figured that out because we did it in reverse. And that equals what? P. So we're trying to do this the same way every time so we don't make it confusing, okay? All right. We know that 0.8 times 0.8 is what? Well, you are right if you said 0.64. So all right, we want to take P, we want to find P squared this time, right? P squared. So that's going to equal 0.8 times 0.8. Whoops. Okay, how about if I actually have a point? 0.8. How about 8? 8 times 0.8. All right. Now, I'm going to show you on the calculator because we always want to check our answers that way. So we're going to clear this. And I could go 0.8 and I could square it, and I'm going to get 0.64, just like what I said. Or again, I can take 0.8 times 0.8. That's actually squaring the number, and I still get 0.64. All right, so right here, the answer is 0.64. And that equals p squared. And we know that. And that means there's 64% of the individuals that have the dominant trait. So right away, we look at it and we go, okay, this has 4% that have the recessive. This has 64% for the positive. It's moving towards the positive trait, whether that's Rh positive or Rh negative. It's moving towards Rh positive. Remember, we said that was dominant. All right, the only last thing we have to do, and this we should probably be able to do without a calculator, but I will still show you. So we have to take 0.8, hello, 0.8 times 0.2. So what's 8 times 2 is 16, times 2 is 32. Now, that's going to equal 0.32. So that's 32% are going to have 2 PQ. Now, I did PG again. All right, so what does that actually mean? Let's figure this all out. All right, let's see if it doesn't block it. All right, in this population right here, we're going to have 4% of the population that are going to have Rh negative. That's all. There's going to be 80% that are Rh positive and have 2 dominant genes. Okay, so they're homozygous dominant for it. Actually, that's not true. 64% have the dominant gene. That was just the alleles themselves. And then finally, 32%, okay, are going to have heterozygous. So they're going to have 1 big, 1 small, 2 big, and 2 small letters. Now, shouldn't all this, 64, 32, and 4, add up to 100? Well, if I take 3 and 6, that's 9. And I take these 2, that's 6. So that's 96 right here. And I add 4 to it, and I get 100. All right. I hope you found this helpful. Please watch the video over and over and just follow these 4 steps every time. Okay. Have a wonderful and blessed evening.